Okay, hello everyone. Today I'm going to be discussing Sober's tautology problem in evolutionary theory, which he introduces in chapter 3 of the textbook. Okay, so I'm going to start off with a little bit of an introduction to the topic. So we're going to go over what is a tautology, and how Herbert Spencer's phrase survival of the fittest has been used to challenge the scientific status of a theory of evolution. The argument illuminated by Sober in the text surrounds criticism raised by creationists and others surrounding evolutionary theory. They claim the theory is untestable because fitness is defined in terms of survivorship. Just to give a basic outline of the criticism offered by creationists and others, they consider the theory of evolution to be A, untestable, B, empirically unproven, and C, a tautology. And we'll kind of touch on all of these throughout the presentation. So, what exactly is a tautology? You may recall from earlier units of this class, a tautology is a declarative statement or proposition containing circular truth value. It is important to note that while all tautologies are propositions, not all propositions are tautologies. So here I've provided a few examples. In the first example, the logical structure essentially states, if not P, then not P. While this takes the form of a proposition, it is inherently repetitive and its truth value is self-evident. It tells us nothing we could not understand by the virtue of its structure alone. This is like the statement, it is what it is. The second statement offers a wider application of the term tautology, which hinges on the meaning of its terms rather than its implicit structure. This is called an analytic statement or a definitional truth. It essentially defines bachelor but tells us nothing unexpected about its concepts. A synthetic statement, on the other hand, synthesizes distinct concepts in one proposition, so that the truth value is not inherent within the statement, but refers to something external which must be proven true through empirical methods. These distinctions are important to understanding the criticism towards fitness and evolution as a scientific theory. So, is the survival of the fittest a tautology? At face value, the survival of the fittest is not even a declarative sentence, and therefore cannot be a tautology as they are propositions only. To test for tautologies, then, we must then analyze particular propositions within the overarching theory of evolution. Here I have illustrated the foundation of the tautology problem as it is presented by critics. In this simplified form, it is evident why this criticism exists. However, as Sober breaks down the components of this argument, its misguided interpretation is made more clear. To examine whether the theory of evolution or fitness as a concept are tautologous, it is vital to analyze the parts of the theory rather than jumping to a significant generalization, negating its particulars. To do so, Sober offers examples of what an analysis of these propositions would look like. He lays out two propositions regarding the concept of fitness to illuminate this process. The first one is the traits found in contemporary populations are present because those populations were descended from ancestral populations in which those traits were the fittest of the variants available. This proposition is not a tautology since, as Sober states, present populations descending from ancestral populations is not a logical truth. Although, Sober also clarifies that this statement is considered a synthetic falsehood because it negates possible reasons other than natural selection that may result in traits reaching fixation or totality, such as random genetic drift, mutation, and migration. Regardless, Sober has just provided a statement which emerges from evolutionary theory that is not a tautology. In the second statement, trait X is fitter than trait Y if and only if X has a higher probability of survival and or a greater expectation of reproductive success than Y, Sober offers a sufficient definitional statement regarding fitness, which he considers a tautology. This analysis reveals that although the theory of evolution contains tautologies such as this one, it is important to differentiate the parts from the whole. Critics often conflate tautologous statements within the theory as representative of the validity in its entirety. It is easy to create these analytic statements while disregarding the infinite other logical truths and synthetic statements surrounding the theory. Unlike the previous statements mentioned, These synthetic historical hypotheses refer to an external concept, terrestrial life, and how it came to exhibit its present characteristics. At this point in the argument, Sober makes a clear delineation between empirical statements like those that compose the general laws of physics and non-empirical truth, such as the mathematical truths evident in evolutionary biology. These historical hypotheses cannot be deduced from definition alone, and so are not indicative of analytic statements or pure tautologies. He goes on to say that historical hypotheses describe properties of the particular objects found in the tree of life. These hypotheses are empirical. On the other hand, Sober acknowledges that many evolutionary models, when reduced to their core characteristics, arrive at non-empirical mathematical truths. He offers two examples of these non-empirical principles of evolutionary theory. First, Fisher's sex ratio argument, which outlines how competition between males and females within a species results in the convergence on a 1-to-1 ratio, as any imbalance would give the minority sex the competitive advantage, eventually leading back to an equilibrium. Secondly, he refers to the Hardy-Weinberg law, which allows the computation of frequencies of different genotypes in organisms from the frequencies of gametes that produce them. These models are characterized by mathematical truths, arrived at independently of experience. He compares these non-empirical truths to the general laws in physics, which are experience-dependent and are ascribed greater levels of importance than the mathematical truths of other sciences. This rationale is what casts evolutionary theory into the realm of tautology, according to creationists and other critics, when it comes to determining the scientific status of evolution. Sober would argue, however, that these discoveries are of equal importance to the scientific pursuit, regardless of whether they reach to some external observable fact of nature. To further Sober's argument of the importance of non-empirical truths, it is important to mention Quine's perspective on the indispensability argument. Like Sober, Quine believes there is an inherent importance to be discovered in non-empirical truths outside of their application to experience. He refutes the idea of truth by convention, like when we assume analytic statements are tautologies. He argues that the logical truths we may arrive at through the postulations are adoptions made with the justification of elegance and convenience. Let us take, for example, physics. Within the theory of relativity, mathematical equations are offered that cohere with the general theory. However, these equations are part of a larger set, like is defined within set theory, which expands past the limited space by which they are being applied. Quine and Sober argue that this picking and choosing of mathematical formulations to fit a naturalistic theory does not detract from the justification of the remaining equations in the set. Quine argues that mathematical truths are often considered useful only when they further the natural sciences. In his view, there are numerous instances where the reach of mathematical truths expands past the limits of naturalistic investigation, and yet are still applicable to the molding of scientific theories generally. For Sober, this includes those mathematical truths surrounding evolutionary theory that may seem unimportant or trivial. In reality, from a human perspective, certain statements are chosen axioms by which we make indispensable to our theories, while those that lie outside of this depiction are still justified but maybe not necessary. In conclusion, Sober has illuminated the misguided attempt to label the theory of evolution as a mere tautology. Creationists and others oversimplify the statements made within the theory, using analytic tautologies to invalidate its claims. Quine expands this reasoning to the wider realm of science, critiquing the use of postulations of natural theories as conventions of truth, rather than investigating the set of mathematical principles they contain. Claiming the notion of survival of the fittest is tautologist completely discounts the non-empirical mathematical foundations and historical hypotheses that underlie the theory of evolution and the concept of fitness as a consequence of natural selection. This is additionally problematic if we are to consider natural sciences like physics different, even though they utilize the same postulation methods and chosen axioms to justify their claims. The theory of evolution is far-reaching and spans beyond an indispensability to natural sciences like physics. While mathematics can be used to represent its models, the results are deep, non-obvious, and provide important guides to understanding the world. Thank you everyone for listening. I hope this taught you something about the tautology argument presented by Sober, and here are the references I used in the presentation.